Hi, it's Gadget UK here again. This time we are looking at an Amiga 2000 motherboard. Now I do also have a full 2000 on the way, well, minus keyboard. But anyway, we'll cover that in the next video, I think. I might have to split this into a few videos because I don't think this is going to be an easy, straightforward repair. The first thing I would say is it came in a giant box, I'll show you in a minute, which is really good of the seller. It came all the way from Germany, this. Commodore, I think their headquarters for Europe were in Germany back in the late 80s, 90s. I could be wrong, I think they were, because I remember seeing the GmbH, whatever it is, the Commodore thing on the end there, to show it's a German company there. So yeah, well packaged. You can see he's taped some card. I guess this is the only thing you could do if you've not got a large enough ESD bag. Bear in mind with paper you can still get, ESD, I think you can, capacitors have paper in there, don't they? But it's better than it just being wrapped in bubble wrap. So yeah, I'll continue to cut this open, we'll have a look inside. And it could be eBay's own packing service actually, because it's got eBay tape all around the box there. So you can see straight away, corrosion damage, battery, where's the battery not being removed? Yeah, so it's, Revenge of Varta parts, 5001 I think, I've got that many battery leakage things on my channel. So yeah, does it look moderate? Does it look major? I would say at this stage moderate actually. I mean, it looks pretty bad right down the bottom where the battery is, but there's not many traces. The most damaged bit is here. You can see the wires and things around there, are fairly well weathered. So if we just have a look through the slots here, because this is another thing you need to look for to see if you've got any green connections in the slots. Yeah, there's a little bit of corrosion up there, let me show you. Yeah, so zooming in a bit, I don't know if you can see some green pins there and something like fluff or something's landed in there, so let's get that way. Yeah, you can see that now, green, 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 green. 6 green pins there, so that's going to need cleaning up. That cap looks a bit mangled on the end there. It could be that cap that's leaked actually. That might be why we've got some corrosion up there. Yeah, audio jack has been knocked to the side there. I don't know what version of Kickstart we've got, we can have a look at that in a minute. You can see where the power connector goes here from the power supply. So yeah, in theory it did cross my mind that I could just wire up, plus 5 ground, plus 12, and minus 12, presumably that goes there as well. And power it that way, with some bodge wires soldered on the underside, or I could buy a connector for that. And in fact, from, I think it's Amiga kit, sells an adapter, it's crazy price, it's 15 quid to go from that to ATX. So that's a possibility, but I thought for the start of this video, before we look at this board, I'll wait for the machine to arrive, but we'll just cover some of the things here. I'll just give you a bit of an overview of what's on the board and have a bit of a waffle. We've got the 8371 Fat Agnes, and actually if I just move the camera a little bit, I don't know if you can see on this board, it's called the Fat Lady. So she's had a promotion in title. It's the same chip though, you can take an 8371 from a 500 board and just swap it in here. And likewise you can put an 8372 in here, an 8372A. I think if you do that, you'll need to deal with the NTSC PAL pin. Because as I said in an earlier video, when we covered the Agnes chips here, the 8371, this is PAL specific, and the 8372 is PAL or NTSC switchable via a pin. And that was a change they did. So, and this socket was never intended to support originally the 8372A. So I think the pin that goes to that NTSC PAL pin has got a high there or something, and it needs to be isolated or fed low. I could be wrong. It might be the other way around. We'll have a look at that, because I'm going to fit an 8372A on here. As you can see, lots of lovely DRAM. Lovely is perhaps not the right word. Lots of terrible DRAM, because you get a fault in one of these, it can be a pain to diagnose. And when on some of these boards, certainly 500 boards I've seen in the past, you don't just get one failed, you get like several or nearly all of them failed. So yeah, they can be pretty fiddly to work on when you've got RAM issues on these. And there are 32 of these, not 16, so we have 1 megabyte on this board as default. So because we've got the half meg Fat Agnes here, it's going to be half a meg chip, half a meg slow, other, pseudo fast. So for the most part, this board is very, very similar in capability to a 500. You know, you've got Gary, standard Gary chip, Paula, Denise. You can uprate Denise. As I said, you can stick the 1 meg Agnes. You can uprate the Agnes to an 8375 or something similar, but you would need one of those little adapters. You can get a little adapter that plugs in there, adapts to the 8375, and gives you 2 meg of chip. You know, usually, typically, those boards will have a little 1 meg on there, an extra 1 meg of chip. So you've got 1 meg down there, 1 meg on the little PCB that goes with the adapter there. And your even and odd CIA chips here, 85208-1. The A-1 seemed to be slightly later revision, I think. Although if you look at the date on these, 25th week of 87, these were super early. There are a number of different revisions of these Amiga 2000 motherboards, actually. This is a B2000CR. It's got the names there of Haney, David Haney, is it? And Fisher, yeah, the original people who worked on this board revision here. So it says AW 312723 Rev 4. So yeah, there are several different revisions. I might talk about some of those later. I'm guessing this here is for the power LED. It might not be. It could be for hard disk or something else. I don't know. So these 5 slots here are Zorro 2 slots. This, I believe, is the processor slot here, so you could fit you know, a card that plugs in here. Commodore had a few of their own different models. I'll stick them up there. There was a 68020 processor, a 68030. You could get a board that had a support for a 68040, and I think on that same 68040 board there's a little adapter PCB you can get that plugs in and gives you an 060 processor. So there were quite a lot of expandability options using the CPU slot here, and you didn't need to, you know, like on the other Amigas, you can just leave this here. That was something designed in right from the start with the Amiga, the fact that you could inhibit, you know, disable the CPU via one of the pins on the Zorro bus there. On the A500 it was on the side, you know, from the side connection you could actually disable the CPU, but I'm guessing from these slots here you could, well, certainly this one, I'm not sure about the normal Zorro slots here, but the processor slot here, yeah, you can disable the CPU via, I don't know, pulling a certain pin low, presumably. So the battery will have to come off. I might just cut that off in a minute and just show you. It's not going to corrode any further by just leaving that on there for another day or two, because all this corrosion will have been done many years ago, you know, several years ago. I remember when I got my 2000, it had a similar, well, not quite as bad as this, a level of corrosion around the battery, and this was back in, I don't know, 1992-ish, something like that. I think I got a 2000. And I removed the battery on that, and funnily enough I replaced it at the time. It seemed like a good idea back then. But yeah, if you're going to replace the battery on this, what I would do is put a different type of battery on there, maybe, you know, like a, I don't know, a lithium ion rechargeable, because those don't leak. Or you could have wires coming off to somewhere inside the case and have a little sealed battery module, some container of some sort to hold the battery in. So that it doesn't leak all over the board again. But yeah, I won't be swapping that back out with another Varta, that's for sure. The ROM socket's going to have to come off. This chip socket's going to have to come off. We'll take that chip out in a minute, just have a look at how bad the socket is. And then some of these resistor packs are going to have to come off around here as well. I think we're going to be alright up over here, although yeah, this chip here, not so sure about. And then it's just whatever traces around here are damaged. I'm hoping there's not too many. There might be a fair few around the CPU, and certainly around that resistor pack there, but here it looks like there's just 3 or 4. I don't know, it's hard to see, the traces aren't even visible, are they? There could be several traces around there. So what's so interesting about Gary here? Well, you can see straight away the part number is slightly different, CBM 5719. And underneath it, I spotted this very early actually when I first looked at the board. I thought, that's a bit strange, what's that? And I went away to go look it up, because I wondered if this was a PLD or something, because the part number there in the middle, it starts TC17G008AP-0025. It's a Toshiba part number, that. If you've done anything with Neo Geos, you'll recognise the TC and even the font of that there, and the Japan bit at the bottom, and recognise that as a Toshiba manufactured part. Now the interesting thing with that, it goes a bit beyond just the fact that Toshiba manufactured it. There's a bug in this version of Gary. So on the later 2000s, I think by the time you got to like 4.1 or 4.2, they started swapping this out with the MOS version of the 5719, which had that fixing. So it'll be interesting to see how that behaves. My understanding is some software might not work with it properly. So for example, I think I read an article somewhere while I was searching. There's very little information about this out there actually. If you know more about it, please post below. But the small snippets of information I could find is someone else had this same chip, and he found that I think Rainbow Islands wouldn't work correctly. It was like stuttering or something, and there was a problem updating the screen. So yeah, we could perhaps give that a try. But yeah, that's one of the things I would swap out. I will swap that out. Once we've done a bit of investigation to see how it behaves, I'll swap that out with a Moss Gary chip. And at the top of the board here, you can see there's the video hybrid. Same, I'm guessing it's exactly the same pin out there as you get on a 500 and 500 plus. Some corrosion, I can show you later in the pins there. So I'm not sure what I'm going to do about that. I might just remove the connector and see if I can pull the pins out and clean them up. And there's a few here that are corroded as well. This is the video slots, so you can plug graphics cards into here. Now, again, there are lots of different revisions of these boards. Probably more. In fact, there are more revisions to these boards than there were to the 500. And some of the earlier ones had, I think, a pin or two missing from here. In fact, the very early ones had lots of pins different on here. So, but by the time they got up to about, I don't know, ref 4.1 or maybe ref 4, this one might be all right. They connected those missing pins there. But I think in principle, most of the connections go straight to the video port. I'm guessing that's what that is there. I can't tell from, yeah, I think it is. That's male pins on the back there. But yeah, those are all connected there. But I think some of the other, there are some other connections on the board that lead to this as well. But yeah, you can plug in, you know, I don't know, a Picasso graphics card or something like that, presumably. So you've got your floppy interface here. It's interesting, there's a little header here. I'm not sure what that's for. It might be something to do with what one of the two of these ports here. You might be able to have additional serial or parallel connections there. I'm honestly not sure. And then over here we've got Buster. So this is the only large custom chip on here that differs from a 500 or a 500 plus. And Buster, I think, provides the arbitration for some of the DMA stuff. The bus, you know, the DMA connections required for all of the slots here, the Zorro slots and stuff. And up here you've got PC slots here. These are XT, you know, so 8-bit. You know, the type of slots you'd get in an 8088 or an 8086 machine. And then the AT 16-bit slots here, you know, so these are the bits that extended it to make it 16-bit. So there's 4 of those, and by default those don't do anything at all. Yeah, I think the power and the ground connections and things obviously are connected to the relevant supply rails on the board, but these serve no purpose other than just being placeholders on there. One thing you can do is you can extend the slots here. You can see this position for, you know, the two of the bits here to have 4 16-bit slots there. But the idea behind these is you plug in a bridge board that gives you, I think there'll be a processor card or something connected to that. Maybe, I don't know whether there was a 2861 one. It might just be, well, it must be, because 16-bit. There must have been at least a 286 processor board that you could plug in here. So you had, and it, you know, it's like a bridge. So you had to use one of these slots here. I'm guessing if it's a 16-bit one, you had to use one of these. If it's an 8-bit card, you might be able to use one of these here. But then it frees up, it leaves you 3 slots for use with that PC, if you see what I mean. I've got no idea how you would switch between the PC and the Amiga, or whether they could run in parallel. You might be able to get the PC up in a window, you know, on Workbench. I've got honestly no idea. It's not something I know anything about. I could go away and research it, but we might discover as we go on through these videos. Yeah, so you had to think about where you plugged that bridge board in. If you plugged it in here, it meant you got these 3 slots. If you plugged it in there, it might hinder this one. I don't know, depending on which side the components and things on the card were, but you'd have to think about that sort of stuff, depending, you know, what you wanted to do with each slot. And the other thing to think about is the Zorro slots here, the first 2, are in line with these AT slots here, the 16-bit PC slots. So if you had a full-length card, I don't know, a memory expansion or a hard disk controller or something that came all the way along here, it would obscure that Zorro slot. So yeah, that's something to consider. So there are a few jumper positions on the board here, and that's a CN, so I'm guessing that's for a connector. I don't think there's like a jumper missing. It could be the power LED. Again, you can see one down here, CN something. So again, that's for a connection to, I don't know, something on the front. That might be floppy and hard disk. I honestly don't know. Your Oki real-time clock chip is down here, you know, that goes powered by your battery here, and then we've got you know, TTL stuff here, so you know, 245s and things like that, maybe the odd 244, I'm not sure. So again, this is going to be for the Zorro stuff here. Another bunch of TTL chips here. Again, it's all going to be related to the bus stuff for these slots, you know, control, logic and stuff. So on the back here, I think that's video output, because it's like 23 pin, isn't it, instead of 25. And then we must have, I don't know, serial. One of these must be a disk drive. Is that the narrow one? I think it probably is. That might be for disk drive. And parallel, serial parallel. I've got them, might have those the wrong way around. And then obviously, you know, composite. I'm guessing it might be monochrome. Yeah, we'll soon find out with that. And then left, right audio. You can see that jack there needs straightening up. It's been knocked to the side. And on the front side of the board, there's your keyboard connector there. And obviously your two controller ports here for your mouse and joysticks and stuff. So again, looking dirty. Look at all the fluff down there, and that looks a bit grey inside that. So I've got a few of these nice turn pin sockets here. Before I do anything though, like I say, I'm going to wait for the main system to arrive, which won't take long for you because you're just going to be waiting a few seconds. But right now I think I just want to just try and get the CPU out here, just gradually ease it out. So just gradually easing the CPU out a little bit on each side here. It'll just be interesting to see how badly corroded the pins are, and I hope we don't lose any of them. I mean, I've got plenty, well, I say plenty, 5 or 6 I think of these CPUs if we do need to replace it, but it would be nice to try and save it. It's proving difficult to get out. Yeah, there we go. So yeah, you can see the pins on there are very dirty, but we haven't lost any pins. Let's just put the CPU over there. Yeah, so a bit of a zoom in there, you can see just how green some of these are. So I wouldn't just clean this and then hope for the best. I would remove this. I mean, I might do in terms of testing, I don't know, I might just give it a test after I've cleaned it, but then we will remove this and clean up all around there. So although the other machine has not arrived yet, I think we'll cut this off. So I mean, I could, you know, try and desolder it, but the solder's not going to melt very well, so I'll just very carefully cut the contacts here if I can. It's going to be pretty thick at that point. Just try and cut that side. Yeah, I might need to revisit those in a sec. Let's just try the one on that side. It's quite thick at that point. That's one of the problems with this. You know, the snips, I've got super sharp snips here. There you go, and it didn't want to cut into it. You can see that's coming off there now. So we'll just snip that one a little bit more. There we go. If we just wiggle that around a little bit, it'll come off, I'm sure. It's just hanging on there, look. Yeah, a bit sharp in terms of the point there, but at least that's off. It wouldn't corrode anymore, but I just want it off there while I'm cleaning. And as I say, yeah, I need to be careful there because I'm going to get my fingers caught on those bits. But yeah, we'll choose some vinegar. This is white distilled vinegar here. And I'm just going to go over all of the area around here. I'll get the toothbrush onto it as well in a minute. And we'll just clean up and just see what it looks like after it's had a light clean with some vinegar here. The bits I'm not looking forward to on this, if I'm honest, it's these extended areas like here, all of this here. There's loads of corrosion, you know, you can see it here around some of the connections there. Some of that might just be stitches for the grounds, but yeah, there's a few traces I can see going to those actually. So I'm going to have quite a few wires on this by the time we are done. But anyway, you can see it's all coming off there. It's just going to take some time going over this with some vinegar. Well, it's no surprise, the cotton buds are obviously coming out super dark green, and I got my finger on a bit of the stuff on the other side of the cotton bud, and it started to irritate. I think the alkaline on there is really strong on this particular one. I mean, it could be the vinegar that was stinging my finger there, I'm not sure, maybe got a small cut on it or something, but I could feel it nevertheless. It's pretty rare for me to be able to feel something affecting my skin like that when I'm doing this kind of work. Yeah, we'll get the toothbrush onto this area here and just get a bit more vinegar, you know, fill the whole area there and leave it for a few minutes as I scrub around, I think. So I'll get a little bit of vinegar into a cap here and get the toothbrush in there and just have a bit of a scrub. We'll do around that resistor part there. Get some under the ROM here as well, I think. I should take that ROM out. I'll do that in a minute, just have a look at that socket, because that's probably going to need swapping. Hopefully the Agnes, Fat Agnes socket there, you know, Lady Agnes or Fat Lady, whatever she's called, on this board is okay. And the keyboard connector, I might take that off as well. It really does depend on inspection, depends on what I see. If it looks like any of the pins are corroded around the keyboard connector, I'll obviously take it off. Anyway, let's just try and give these pins a bit of a go here. You can see I started to scratch off 2 little traces under the chip there. There's a couple of bits of corrosion there that I thought I'll just scratch that, see how corroded it actually is, and yeah, it looks like they might both be broken actually. I mean, so if that's any indication, if one of the pins underneath, you know, a couple of traces underneath were only looking lightly corroded, yet they look like they've gone all the way through, it doesn't bode well. And I'll just mop that all up with some cotton buds and paper towel. But I'll leave it on there for a good 5 minutes, just to let it float around and, you know, eat its way in, I guess. So I've mopped up a bit around there. Let's just take the ROM out. As I say, I should have done that before I started cleaning it, really, you know, cleaning this around the socket. I believe it's got 1.3 this, well, if the advert's to be believed. This is a Sharp chip, I think. You can tell because Sharps begin with that LH there on the part number. But yeah, the pins look alright, that look good as new actually. Yeah, hopefully you can see how bad those are, so yeah, that did need to come out. So what we're going to have to do, can you see I've just been scratching that little bit of corrosion there around the 2 wires. I think that's just like ground stitching to go through to the other side, but we need to get them all back to bare copper like that, you know, so there's going to be an incredible amount of work here. But I'm not going to do that work now until I've actually tested the board. I'd just like to see what it's doing. It's always nice to see what it's doing before and certainly after you've done the work there. But what I figure we can do is clean up the connections on these here just with a bit of vinegar. So we'll just get some vinegar on there. And I guess we're going to need to go over these with a few different things actually. I might need to use something like the fiberglass pen to get corrosion off the tips of these, because you see they're still very dark there. And then we might want to solder plate them, you know, cover them in solder again, get a bit of flux on there, use some desolder braid and drag over them to coat them in solder. But I suspect we'll be able to reuse these chips actually. I don't think there's going to be anything wrong with them. It might be good to do that before we come to test it actually. I can cover them with solder. I'll do that next. And then just get them back in there, wait for the power supply and stuff to arrive. Yeah, we do need to do something more there. So I've just got some lightly abrasive sandpaper here. I'm just going around in circles on the, in different directions here on the surface there. The solder on them that was, you know, because they were solder covered, solder coated, the solder's gone weird, like the solder does on the motherboards. You've got to use more friction to get it off. Vinegar and stuff on its own is not enough. But what I will do when I've got these looking a bit cleaner is go over them with some deoxit. I'll show you that. Maybe finish them with a bit of vinegar before I try and solder the surfaces of these again. I mean, they come up a bit better, can you see that? But still, look at this, it's awfully dark here where the solder's been affected by the alkaline. So you know what, it's not too bad, it's fairly superficial. This is the side where there were only just 6 or 7 here, and I've got some deoxit on there, and then I've used the fiberglass pen as well at the same time, and I've managed to clean these up pretty well actually. The pins here don't look bad. They were all really, really dark and dull. Can you see these ones here? They're still looking pretty dark and dull, so there's been a bit of deoxit still on there now. So again, you're not going to be able to see this very well, and I might knock the camera while I'm doing this, but we'll just try and go over those lightly with the fiberglass pen here. Yeah, that's bringing them up. It's bringing off the corrosion there. But I would, re-tin these with fresh solder. So the other thing I'm going to do while I'm waiting is just test the CPU here and the ROM on one of those 500 boards, so you can see they look a lot cleaner. You know, they're not perfect, a lot cleaner. This side here wasn't really affected, you can see, you know, it's got a nice solder coating on it. So these ones I will, let's say, get some flux and the solder braid and tin that up. I might do that in a sec. But right now, there's a hair there. Right now, I'm going to go and try this, as I say, on the 500 board. One way you can clean the inside of the pins is put it flat on the PCB, on an area you're going to clean on the PCB, and just use the fiberglass pen, like that. So I was able to clean up, as you can see, this one. It looks brand new. That one doesn't even need solder coating. Nothing's worn off it. You might need a bit more cleaning just there, but actually that ROM is okay, despite the fact the socket was super green. So yeah, I'm going to go give these a try. So 68k swapped out for the crusty 2000 68k. Yeah. So I'll tin up the pins on that CPU now, but I'm confident that those chips are both okay. So we're covering old ground again here. You know, this is stuff we did on the previous videos, but a little bit of flux onto the pins there, and we'll just carefully try and drag over these with the solder braid. You can see I'm too eager to get going on this, so I start to just clean up a little bit there. I'll show you some more of the cleanup work as we get through this, but I don't want to clean any more. One thing I do want to do before the power supply arrives is remove the fat lady. So we'll use the PLCC extractor now. Now, one or two people have suggested the best way to do this is to do nothing but squeeze, but I don't like doing that. I'll tell you why, because once you get to a certain point where it's under the chip and it's gripping really tightly, as you squeeze you get an outward pressure on the corners. I'll show you that as once we've pulled it out. But if you just squeeze and pull carefully, you'll see it comes out. But if you do nothing but squeeze, let me see if I can show you. As you squeeze, you get like an outward pressure like that if you're not careful. You're going to go in outwards onto the edges. So I found the best way to do it is to squeeze fairly tightly and then pull very carefully. And you saw that came out without any issue there. So just inspect around the chip there, make sure our fat Agnes is okay, which it is, and just inspect inside the socket. The other thing I will do in preparation is just straighten out some of these caps. Sometimes they can get squashed right down so that, say this leg here, can you see it's extended out a little bit, ends up pressing onto a trace nearby. That's something you've got to be careful of, especially when a board has been stored on tops of other boards. There's one here, look, you can see like that. I'm going to be replacing these anyway, but I just like to just carefully, lightly if I can, just move one or two of these and just make sure they're straight as possible. You see, look at that one there, it's totally flat onto the PCB. It's because it's been knocked and bashed and thrown around. Yeah, that's standing off a little bit now, can you see that? It only happens when the legs were quite long from manufacture, and as I say, when the board has been bashed around, they're alright. They're not straight, but they're okay. So a few days later, and the power supply has arrived. So you can see I've took it out of the 2000 case. We'll look at that in one of the next videos. Got it connected up, it's powered on, and I've got the video connected, I'll show you. And that's what we're getting, a black screen. So I've switched it off. Yeah, so you can see it's actually switching the channel over. We are getting a signal, but it's just black. So yeah, I mean, I could try putting a bit of pressure on those chips. The chips are definitely incorrect, but we've got a broken trace there somewhere that's stopping it from booting. I mean, that's assuming that the Agnes is okay on this. I could measure the clock pin on the CPU there just to make sure we've got a clock, but I think we wouldn't perhaps get a video, you know, a black screen there, I think, if the clock was missing actually. So I think I might just dive in and remove the two sockets next actually, and just start fixing the board, really, fixing the traces around there, work out what's perhaps broken and what's not. So I'm going to start by desoldering the ROM socket here. Then I think we'll remove this socket and these resistor packs as well. I think that one on there might be alright, but these ones here will, well, that one might be alright as well. These ones here are definitely going to have to come off. So I've added a little bit of solder and flux onto each of the connections on that side. I'll do that side in a minute. We'll just see how I get on with this side. Some of the pins are going to be easier to do than others. Yeah, you see that one's not unblocked very well, and I suspect that's probably a supply pin or the ground pin. But the other problem you can get is the corrosion. You know, the corrosion on the solder there. Yeah, it's come off there now. Can make it hard for to get the solder to flow. The other thing you can do is cut these sockets off. I might have to resort to cutting it off yet. I don't know. We'll just see. But yeah, right now they seem to be coming off okay. The solder is unblocking from both sides. Yeah, nicely. Yeah, so doing the other side now, I've got a big blob of solder there with two joined together. Regards to temperature, I'm around the 400 degrees mark here. Only wiggling lightly because I don't want to lose any pads. So most of the solder is off there. I might need to just revisit one or two of these, but we'll just do the usual thing here of just grabbing 3 or 4 pins and just pivot a little bit to help snap them off the sides of the board. As I say, I might end up cutting this off, and you know what? It's not going to be any big loss if I do, because the socket is pretty much unusable. You know, the pins are awful on it. You wouldn't really want to keep it on a board or put it back on a board. So it's partially lifted up here. Hang on. Yeah, I think it's, there we go, it's off. So no damage, but you can see the pins that weren't free completely have just broken through the top of the thing there. So the good news is no extra damage or anything there. I just need to just pull the remaining pins out here. So the bits that are left, I'll probably just heat and pull through from the other side. They were all wiggling on the other side, but on this side they seem to be stuck on there. So anyway, the main thing is I haven't done any more damage to it. So I gently heated from the other side and pulled those pins through. I just need to clean up with a bit of cotton bud and IPA and get some vinegar and stuff. So yeah, I'll just show you what that looks like up close after I've cleaned around it. So a bit of a progress update. You can see I've been scratching the traces here wherever there's been corrosion on top of the traces. There's a bit there. I'll show you some of these in a minute. I'll clean some of this up and I'll give you a bit of a macro as I do that. But you can see, you know, I've managed to clean off a lot of the corrosion around the ROM area here. There's just some wires down here, some traces here, more wires, edges of traces here to do, wires. So the next thing I'm going to do is remove these resistor packs, I think, and the socket. Then I might remove this chip over here, but yeah, I'll start with these resistor packs here, I think. So as you can see, I desoldered the connections on the resistor pack there. It's not freeing up, because despite looking like the solder's gone from there, on the top side it's so corroded it is not melting properly and not coming off with the desolder station. So just for the moment I moved on to the 68,000 socket. This one is proving a bit easier. It might be because the thermal mass of the socket is nowhere near the same as the resistor part there. But you can see just giving it a little bit of extended time to pass the heat through to the other side, and then wobble the pin around. You can feel when it's molten, and the solder's then coming out. You don't want to put a lot of pressure on, because obviously you could cause a floating pad. You know, the pad could come off. But you do need to give it the additional time if the solder's corroded on the other side, which it is. Any that aren't moving, you can always just give them another go with the solder station. Let's just clean this stuff off there. Yeah, that second one's not moving very much. Let's give that another go. There you go, it's free now. At this point we can determine if it's free. Can you see on the side here, can you see it's just wobbling? All these pins here, see them all free. Got one or two here that are stuck. And this is the thing, you're going to get the ones near the battery, the ones that are nearest the battery are going to be the problematic ones. The top side here, yeah, not quite free. So I'll continue inspecting underneath and just flicking the pins from the underside just to make sure they're free, and use the desolder station on any that aren't free, and then we'll try and pull that off. So yeah, that entire side is off. Can you see that? That side's no problem at all. I really didn't want to do that. I need to somehow now try and ease this out in such a way that we don't damage the pads here. All the pins here, can flick them from the other side and they feel loose, but we've just probably just got one or two that aren't. You know, it's going to be somewhere around here where the grounds are, I think. So I don't know whether you're going to be able to see this, but from the other side, just watch, I'm just wobbling the socket slightly. I don't know how well it's going to come out. So I can see like all these pins here wobbling. There's one down here that's not, a third one I think, third one's not wobbling. The ground pin here is not wobbling. Just lightly, you know, wobbling the one side of the socket that's loose, you know, enables me to lift it and just wobble it a little bit. And I can see which pins here are the ones that are not free. Try and cut this off. We'll just see if we can lift it a little bit. Has it come in there? Yeah, something's just come off there. Hope it's not a connection. There we go. Yep, no pads, no through hole plating or anything like that. Just the socket. Yeah, it did need doing. It's awful. Yeah, I'll give you a close-up on that in a minute. Even after cleaning, it's awful. So the next thing we need to do is clean up here. I mean, you can see the residue there, you know, despite the cleaning. Look at all the residue around the edges, you know, that white silhouette there. The solder on the top side here is going to need removing as well, I think, with some flux and desolder braid, because there's some awful crusty solder. There's two damaged traces in between them in the middle there that had a blob of corrosion that I cleaned off right at the start. That might be the issue. That might be the issue, because they do look like breaks. All the things I've looked at over here, I haven't found a break yet actually, which is surprising. There's lots of surface corrosion but no actual issues. I haven't found a single broken connection. Well, yeah, one or two of these down here might be broken, but yeah, and here as well there's lots of black connections there to the edge of the chip. So the next thing I will do here is, where you've got any lumpy solder like that, you know, there's little lumps on this side where the solder's not freed up very well. I think it's just the ground actually, around here, and just one of the connections around there. I'll get a bit of flux on there, use the solder braid and suck that up. So I'm just going to lightly go over these now with the fiberglass pen. Then I'll go over it again with vinegar, and then I'll probably get my scratchy tool onto you know, the surface of these pads here, any that have got lots of corrosion on, you know, because you get like the alkaline affected the solder and you get this horrible stuff stuck on the surface there that just doesn't come free without, unless you use a bit of friction. It's going to need a number of passes this, so we'll end up going over this a few times with vinegar and a few times with the fiberglass pen here. You can see they're not too bad. You can see the black parts of the connections here, you know, the traces. Look at the black sides of the traces there, just leading to the pads. So those are going to need tinning up, but I don't really see any immediate breaks or anything, and this area looks better than actually anticipated. Far better than I anticipated actually. There's a lot less damage there than expected, but those middle two connections, yeah, there could be a break in those. That might just be the issue actually. Obviously you've got black connections here and things, but this primarily seems to relate to the real-time clock by the looks of things. So moving over here, you can see we've still got lots of wires here to clean up and traces as well, but you can see the work I started to do here around the connections on the ROM actually. And again, I couldn't find any damaged connections. Lots of you know, corroded surface area, hence the copper areas there, but no actual disconnects by the looks of things. But I will need to, you know, beep all these out on continuity test on the multimeter. I still need to get that resistor pack off. You know, you can see we removed all the solder from the bottom side and it looked okay, but on this side, yeah, it doesn't look like anything's moved from that resistor pack actually. Yeah, I removed all of the solder from the bottom side on that yellow resistor pack, but you can see it looks like hardly any's come off on this side. So that resistor pack was far easier than I thought as well. I just wobbled it slightly like this from this side, watched the other side, I could see which pins were moving and which weren't, heated the pin that wasn't moving and used the desolder pump there. Just hope I've got no traces or pads or anything attached to this. I think it's coming out. Yeah, there we go. No damage. Yeah, look at that, that's awful. White and furry. So there could be some damage around there. So I'll try and show you some of the work here. It's not dissimilar to what you've seen me do on the 500 plus and even Neo Geo videos here, you've got to, you know, scratch off the corrosion circle on the surface there. Try not to put too much pressure on. What you don't want to do is disintegrate the connections and things there, you know, damage them further. Periodically have a go with the fiberglass pen. You do need magnification. I can't really see what I'm doing here. It looks like there's a gap there. I'm not sure. It could be a bit of the solder mask still. But yeah, nevertheless, this is exactly what you've got to do. So you've got a piece here of the solder mask worn off. Again, you've got to go right up to the pad and make sure it's still joined. But we're going to be tinning over this, just as you've seen me do again in many other videos here. But yeah, you've got to scratch the dark green solder mask coating off there, or it's corroded, and clean with the fiberglass pen. Go over with some vinegar afterwards. But yeah, that's the kind of process really. And you can see this wire here. Again, the stuff that's on it, it's like crystallised alkaline, and it's affected, you know, the surface of the solder there. You couldn't just put flux on that and reflow it. It will not reflow. So you've got to make sure the connection that's going to it is fully exposed, so you can turn over that. And I can't see anything there. That one might be one where it needs a wire. I'm not sure. I can't really see where the trace joins it, if at all. But you can see it's starting to come up now. By the time you've got some vinegar on here and you've repeated this process a few times, very, very carefully, because what you don't want to do is break every single one of these as you're going through them and creating yourself situations where you need extra wires. But yeah, anyway, I think that's perhaps a good example. You can see just how much cleaner that is compared to these here. Yeah, that's not too bad. So I haven't lost a pad yet, just desoldering that little chip there. I think it's a 245, it might be a 373. This side here, where it's not corroded, all of the solder has come off really well. I don't know if you can tell from there, but there's nice little black cavities, you know, around the pin there. This side here, it's like 50% of them have desoldered, even though I've gone over and over and over and over it. So I'm going to use some hot air, I'll show you that. And we'll use this little dip extractor here to remove it. Yeah, I think the desoldering station needed unblocking. That should be just a spring, and that's it. This is a solid piece of solder here, and you can see this is all the solder that has accumulated inside there. But anyway, yeah, it's going to take me some time to cut all that up off the spring now. Well, so far that was the hardest thing to remove, that resistor pack there. Again, no damage. It's all furry, it needs cleaning up, but I'll get the hot air on now and I'll show you removing that little dip chip on the right hand side. So hot air set to around 400. I might need to remove one or two of these resistor packs here yet, but I don't think so. I've inspected those, they look okay. It's just there is some corrosion around the pins here. You can see kind of like a funny looking white mark there. So it just seems like this chip here has just got a little bit of corrosion. And again, it might be like some of the resistor packs where I've took them off and actually they look alright. It's just furry and dirty underneath. But anyway, the trick here is just to kind of preheat the area a bit. It's still heating up here. It's not up to temperature yet. It's getting there. Yeah, so preheat around there for a good 30 seconds or so, and then start to, as it gets up to temperature, which it's doing now, 400. Just focus on the sides of the chip here. I'm fully expecting that ground pin there to be a huge part of the problem with this one. One thing you've got to be careful of here is delaminating the board, and actually to a degree I think I might have just done that. I think maybe we got a bit too much heat here and it might be starting to delaminate. There we go. Yeah, I think if I'd gone at that too much longer I could have started to delaminate the board. I think as things stand it's okay. We haven't got any damage there. But you can see how corroded that is. So yeah, if you're going to use hot air to remove chips from these PCBs, make sure you spend perhaps longer preheating, because preheating is essential. Otherwise you can delaminate boards. You know, the layers, the laminated, and they can separate if you put too much heat in one area too quickly. But yeah, I think we're okay. As that's cooling down now, that's looking okay to me. There's no damage occurred there. So there we go, unblocked some of the blocked holes from the top side here with the desoldering station. I'm just going to do all the cleaning up now and scratching things off, and then I'll show you the tinning up and we'll get the sockets on there. So after about 2 or 3 hours of work there, we are approaching a point where we could start to tin up these. I mean, you can see I'm using vinegar here. A lot of this green stuff is going to be some of the solder mask that I've scratched off. You know, there's lots of powder there from the fiberglass pen. Predominantly I've scratched the traces, you know, to copper to start with, using the little scratchy tool I have, and then used the fiberglass pen to clean up the traces further. But you can see there's a lot of corrosion damage around there. I managed to get it off all this ground area here. You know, it comes off pretty easy, the solder mask, where the corrosion has started to eat. There's 1 or 2 wires still I need to clean up, I think, before I start trying to tin up. But yeah, this trace here needs some work. But I need to inspect super close just to make sure I've got as much of the corrosion off as possible before I try and start to tin. So after buzzing out all of those connections there, you know, making sure that the traces from the left join the pad, and then the you know, from the pad goes through to wherever a via or one of the other pins, you know, so all the way around here, all of the connections, all of these. How many broken traces? None. None at all. These things are bulletproof compared to 500 pluses, which was, yeah, I mean, there's going to be lots of them out there. They've got lots of broken traces, I'm sure, but there is a possibility this board has another fault. You know, maybe the battery was never really the actual issue with this. It could have had failed, got put into storage, and then had the battery leak. But, you know, the connections on the sockets and things were absolutely awful, and there was lots of contaminant between the pins, and it kind of bridges and creates resistance and stuff. So, yeah, we might find just after tinning this up, getting the sockets and the resistor packs back on there, it might just work. I'm going to focus on this area last, I think, because I think primarily this looks like it's real-time clock related. I don't think any of these connections here are going to be relevant, but yeah, I mean, I can always, you know, if we still got a black screen, I can always then just focus on this area and see if that makes any difference. We'll just get some of it around here and just have a go at these and just see how I get on, really. So a tiny bit of solder on bring the desolder braid in, and we'll just have a slide around. Yeah, you can see that's working. It's time consuming, but if you don't cover these, I mean, you know, you could be tempted to just put a solder mask over this now. Now you know they're okay, but they have been corroded, you know, so a certain amount of thickness might have been eaten off them, which means that you get a bit of current going through there. They could burn out super easy. Once I've done this, obviously retest connectivity as well, because we could introduce some faults by doing this. Yeah, but so far I'm pleasantly surprised. It seems to be tinning up okay, and some of these vias will reflow as well, get some fresh solder into those. So I've zoomed you in a little bit just so you can see a bit more clearly, but we'll have a go at these here. Yeah, you can see it's tinning those up nicely there. So the other thing I'll do here is I'll take some close-up photos of these areas here where these chips have been removed, just so that when I get the sockets back on, should one of them break, you know, a connection break somewhere, at least I know how the board is laid out. I think that's unlikely. I mean, I haven't found a single break anywhere, even after the reflowing, but just before I put these on, I'm going to go back with the continuity test now and just check everything again. You know, go down each of the connections here, and then all the traces that pass in between the connections. I do the same for the things to the right hand side here as well, and that chip there, and then just get the sockets back on. So resistor array legs cleaned up with the fiberglass brush. We're just going to test this now, put it on ohms. Yeah, hopefully you can just about see that. There is a bit of reflection. The dot down here on the pin 1 is the common pin. Yeah, try and hold it in place. And if we test each other pin, 10k, 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 it's going to be like a pull up pack this, or pull downs or something. 10k, 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 10k. We'll fit that again. Not very exciting, but nevertheless I'll show you some of the fitting of components here. We'll just get the CPU in there. I've gone with the turn pin. In fact, the turn pin with the only socket I could blooming find for one of these actually. There we go, that's that. Let's get the BIOS in, pin 1 at the top. Yeah, that one's just a dual wipe socket. And I'll just get that one in a sec. So the worrying thing is, it's just the same. Let me just show you what I found, just from a quick test here. I was trying to test connectivity to the ROM. 2 data bits here, shorted. Now I follow the traces. I can't see how they could even be possibly joined. There's nothing on the underside of the socket here to join them. There's nothing on here that could cause it. So somehow pin 3 and 4, well not 3 and 4, this is like 60 some, you know, these second to last, third to last and fourth to last pins here, but those are both separate data bits. They shouldn't be shorted. This is going to be an absolute nightmare to try and find the cause of this one. So short removed, you can see no short. What I ended up doing was taking off all of the chips and testing them, and testing if the short went, and it didn't. The short was there all the time. I measured to the CPU slot here and thought, oh no, I wonder if it's something to do with the CPU slot. Maybe a card's failed that's been plugged into there at some point, and shorted pins 3 and 4. So not 3 and 4, you know, these two here, whichever data bits those are, I'll stick them up there. So I measured connectivity, because what I was looking for was one chip where both of those pins are connected, but that isn't the case. It's like one goes to this chip, one went to that chip, or you see what I mean? And it was the same. It was the same over here. One went to this chip, one went to that chip. So it's not like an internal short on one of these could have been short in those two pins. No connections to the RAM, obviously, because I think that that's isolated by 245s or 244s or something, you know. So it couldn't be the RAM. I'd removed all the other chips, let's say one by one, and the short was still there. So we came back to, you know, Occam's razor. I thought it's got to be, you know, the simplest explanation being the most likely. I thought it's got to be something I've done. And I was casting my mind back about the series of events, you know, leading up to reassembling this. I looked at the photos as well, just to look to see where it might potentially be shorting on here. And I speculated the only place I could see it might be shorting on those two pins is somewhere around here. Now there's a couple of things here. I measured those resistor packs before I put those back on. This one I did not measure. I just assumed it would be okay. That was a big mistake actually in retrospect, and this is kind of one of those fate moments in the sense that this wasn't causing the short, but when I removed this I could see the short. There was a little, I don't know where it was now, there was a little solder blob just bridging the little trace to the connection. So that was the issue there, and then I thought, well, okay, before I put this back on I'm going to measure it, and I measured it. Let me just show you what I found on this. It's an awful coincidence, and it's a different the positions here that are affected are not the positions that we're shorting. So this is really weird. Let's say, you know, I'm a believer in fate, that strange things happen for reasons. Yeah, I need to change the battery in my meter, but just watch this. Right, 10k, go to the next one, 10k, it should be 10k on each of these, 10k, you know, between common and the pins, 10k, and this, watch the next one after this, 10k, the next one, watch, 24k, and next one, 10k, next one, 10k, last one, 10k. So one of these is measuring 24k, and if I measure resistance between the pins, two of the pins here seem to have a short as well, but they are not the pins that were, or maybe they are actually. No, I don't think they are. I don't think they are, because pin 1 goes up that way. Hang on. Yeah, maybe they are. Maybe they are. That's really weird. So maybe this was causing the short. Maybe the solder thing that I found on there was got nothing to do with it. Because I'm thinking about it now, the positions those are in, those might... No, I don't think those data bits don't go through there. Let me just, again, put it on continuity. Let's just test. Beep. Yeah, just for my own sanity here. Yeah, they don't go here. These are addressed... Hang on, that one does. Maybe that's got something to do with it then. Yeah, that's a hell of a coincidence, it really is. Yeah, so one of the pins that was affected there, in fact it's the one next to it, but that's not connected here, so I don't know, I can't make sense of that. But nevertheless, I need a new resistor array. But this is booting, I'll show you this in a minute. Before I do that, I'm just going to do a few things. I took a 470 off here. I'm not going to stick this crusty one back on. I'll replace that, stick a replacement 470. Need to finish cleaning up down here. One of the other things I did do is I followed the two connections here to wherever they go on the real-time clock chip over here, just to make sure those were connected. Actually, they are. Despite how black this whole area is down here, everything's okay. The traces are all fine. These 2000 boards are absolutely bulletproof. How much corrosion have they got to be subjected to before traces break? I have no idea, but certainly this one has really survived well despite the huge amount of corrosion. So before I show you this working, I want to finish cleaning up and stuff as well. So you can see what I've been doing here on this large area of the ground plane here. Just use a wire brush. It's just the quickest way of exposing most of the corrosion there, you know, the copper underneath the corrosion. So just a quick update, you can see, just using the wire brush, trying to avoid where I can, removing the silk screen if I can. Because this area here, you know, all I need to do is get the majority of the corrosion off this. I don't need to get every single tiny little bit from around here. I will use the little scratchy tool to get, you know, right up to some of these traces and stuff, but you can see it's coming off, and just use the vinegar here as well. That actually helps, and that helps remove some of the paint, you know, the solder mask paint here. You can see, look at that, look how green that cotton bud is. So I forgot to mention a little mod I did actually, and based on the component I fitted. The resistor pack that was faulty there, the only one I had was a 9-pin 10K instead of a 10-pin 10K. So, and it's proven quite hard to find a 10-pin one. I guess if I went on like RS Online or DigiKey, I could perhaps find one. But nevertheless, I used the 9-pin pack, and then we were one resistor short, so I just mounted, as you can see, a 10K resistor here across there. Some heat shrink tubing might be an idea, but you know what, that's not going anywhere. So I'll just remove the battery contacts from the underside now, because we cut that off right at the very start. I've gone for a high temperature here, 480. The desoldering station's only just come on actually, so it might not be warm enough at this stage. It takes time to heat up to full temperature. Yeah, it needs another minute or two, I think. Yeah, that contact's alright. That one's going to be a pain because it's ground. Yeah, there we go. Pins come out there, look. And there as well. Yeah, look, one's just fallen through there. And this one should do as well. I might just need to just nudge it. There we go, it's coming out there. Lucky I didn't block the nozzle up. There you go, that one's falling out as well. Lucky I didn't block the nozzle up on my desolder station doing that. What I'm going to do here is pull in the iron as well, actually. This is a good tip for you if you ever get totally unmovable solder points like this. Just add some extra heat. There you go. So just working my way around the main caps that I'm swapping out. I've removed 3 of the 470s. I'll show you one of those in a minute, the removal. I removed the audio coupling caps from here. I'm just going to double check that on the schematics, just in case I've got the wrong capacitors there. I don't think I have. I'm going to fit some of these bipolar Muse audiophile sort of quality, you know, capacitors, but the bipolar. One thing I will point out is not really a correction, but it's a bit an expansion on the subject of these from the videos we've been looking at here on the Amiga. It doesn't make any difference to the audio quality whatsoever. Swapping it for a bipolar. I'll post a link to a video down below. I went searching, you know, researching this myself, just trying to understand what effect it might have, and it probably does have an effect, but it's probably so minor that you can't really see it. You could measure it, I think, with super sensitive equipment, but on a scope looking at a sine wave, you'll see in the video link below, and a scope looking at a sine wave coming in at different frequencies, the difference when you add a bipolar versus a polarized cap, there's just nothing. It's negligible. You can't see the difference, but nevertheless, that's what it should have on there, so that's what I'll fit. Yeah, I've just checked those. C233243. Those are both the audio coupling caps, and the schematic there is the same. I think it's got a 347, yeah, I can see it there, LF347, and it works the same way. You know, you've got a positive and negative on the swings there of the signal, you know, the AC signal that goes out, so it should have bipolar caps. So I've got nice new Nichicon caps there with little red marks on, just to show that I've replaced those ones, because at this point I'm only going to partially recap this board, and I will label it up to remind myself, you know, partially recapped, and stick a little red dot next to it so it's obvious to me which ones have been replaced, and maybe we'll do it in a future video, I don't know. But we'll remove that one next, and I'll try and clean up these connections here. We need to remove this one because the can is all like, the plastic on it has come off. It's had a bit of a bash or something. It might have even leaked, that cap, I don't know. I've removed the one here already. I've removed the one there, you can't quite see it. But there's some green pins here. So technically, I was planning on taking these off and moving the pins, but I'm going to try, it's just surface corrosion on the very tops of the pins, so I'm going to try and clean those in situ, I think. So I'll add some solder to those cap points first. At the same time as trying to hold the cap on the other side, I will then do the solder work, because once you heat it up, you know, you can feel like I can wiggle, I can move it now, I can move that cap. There's a piece of the cap just fell off, actually, you didn't see that, I'll show you in a sec. So I know that that pin is pretty molten. I can wobble around a bit and then remove the solder. You can see that one's free, so it's just this side, and this one will be a pain. I've got no doubt this one's going to be a few seconds at least to pass through. Starting to melt. The cap is moving a little bit, I think. Yeah, it's moving, it's wiggling. At this point, you know, I keep wiggling the cap here to feel how loose it is. I'll then remove the solder. Yeah, most of it's come off, but you know what, there's still some there. So I'll just try and pull it through, and then I'll unblock it with my desolder pump afterwards. It's far easier than trying to unblock with this desolder station. I think the problem here is actually the tip. Just watch as I wobble it. Can you see the tip is not making a snug fit with the end of the you know, element part of the iron there. That's the problem. I don't think it's getting good heat transfer. I either need to swap out the tip, or it's just that this desolder station's awful, and I think it's going to be the latter, actually. I'm having to try and pull this through. So we're nearly there. Let me just try this iron, because this iron does seem to, I don't know, ironically provide more power. There you go, it's come straight out. More power than the solder station. And just added a bit more solder on there, and I'm just going to use the normal desolder pump here, just to show you can, and actually sometimes you can have more success if you've got a crappy desolder station like I've got. Did you see that? It's just unblocked straight away. Trying to do that with the desolder station was proven impossible. Yeah, I shouldn't really moan, it has not really got the right size tip on for this. So as you can see, 470 microfarad, 35 volts, so it's higher. I think the ones that are more with 16 volt. And that can sometimes be an issue, because you've got an ESR associated with the cap, depending on its size and, you know, its rate, microfarad rating and its voltage. But these are super low ESR, you know, FR series. Probably best used in switch mode power supplies and things like that, but it will be fine for this. The positives on this side here, near the hybrid, and the negative is nearest the video interface slot here. So just need to carefully get that on. Yeah, just the right size. So you can see this wire here. This is going to be a factory mod, you know, some correction that was done due to something missing in the on the board there, you know, a missing connection. It might have even been to do with an improvement or a fix, something they spotted, you know, after these boards had been manufactured. Because the cost of manufacturing a board like this, even for Commodore, would have been a lot of money, you know, for something so large. The last thing you want to do is have to redesign and remanufacture a board. You know, you might have, I don't know, manufactured 100,000 copies of the blooming thing. So sticking a little wire like that is, yeah, advantageous really, if it saves you all that money. Yeah, so hopefully you can just about see that. I'll just move the camera a little bit. So yeah, it's eating the surface off, you know, the nice plating off the tops of those, but actually they're okay. And moving across to this one here, this one's even better. There's just little marks on that one there, but actually corrosion's come off. So I've spent far longer on this than it's probably worth spending in this area, because what you could have done, you saw it was all working. I could have literally just, if I wanted, reinforced the two connections with wires and then just left it as it was. Chances are, as long as you've cleaned it with vinegar, it's not going to re-corrode, you know. And again, you could take it further. I could remove all of these components here. You know, we could have a bit of corrosion around the keyboard socket here. I'm not going to know that until I come to test the keyboard. And it's the same with these ferrite beads and caps here. These are just to take the edge off some of the connections coming in, you know, remove any noise. So again, like I say, I could remove everything around here. But I don't see any point because the connections are not on the top side of the PCB. The connections are on the underside of the PCB. Yes, there's a solder point on top, but I've cleaned those up as best as I can. So it's kind of cosmetic. It's kind of irrelevant, really. You know, it serves no purpose other than being cosmetic in nature of how much, you know, work and time you spend on this point here. Just those two connections, and you know, you could argue the connections for the battery as well. I might get a CR2032 onto this in a minute. I might just do that as a mod. I'll just go and have a look at how it's wired. We might have to remove a diode or a resistor. It might be as simple as that. But yeah, as you can see, cleaning up with vinegar, it's looking pretty blooming good, actually. Yeah, so I've had a good inspection around there. I see no reason why we can't just finish this area off now. So yeah, it's going to be quite a thick bit of it there. I didn't really need that much, but you could of course use clear nail varnish, you know, like a nail varnish rather than nail polish. That might be an idea. So you might think that's the end of the video. Actually, there's another fault that has just developed. This is off the floor, by the way. It's not on carpet. I've got it on a box just at the moment, just testing purposes. And I've been using it for a number of hours, and some issues with some games, which I'm not sure whether there's an issue with the chip RAM. I can show you that later. I need to get a keyboard connected up to that to fully diagnose that. But anyway, let me just show you. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15. That's the clock. So we've got a clock. I know it's none of the main custom chips because I've just gone through them all and checked them all, reseated them and then swapped them, and it's just the same. Anyway, so that's pin 15 is the clock. 16, 17, 18. That's reset. It's active low. Stuck in reset. I think that's what's wrong with this. It's got a black screen still. So I think there's a problem with the reset circuitry on this, actually. Now, my first thought was 555. I don't see a 555. Maybe there's a 556 or something somewhere around here. I don't know. So I'm going to go and look at the schematics for this just to work out where the reset comes from on this. But I think, hopefully, touch wood, it looks like it's just a reset problem. And you can see there, that's the behaviour. I mean, this is the behaviour we had right from the start. So it may well be that the corrosion isn't the actual initial fault. At some point, something's going on with the reset side of this. You know, that would explain why we found no bad traces at all, actually. So yeah, I'm kind of pleased with that, because otherwise it would have been a bit of a boring repair, really. Anyway, I'll go look at the schematics now. Well, I'm not 100% sure, but I think I've just spent the last hour chasing a particle of solder, actually. I followed the reset pin to where it was coming out here. You can see I just scratched off the coating of the nail polish there just to access those two wires. And I traced it to this resistor pack here. Just as I was measuring with the probe here, I noticed a particle of solder come loose from the pin I was measuring. So I think maybe it was bridged to one of the connections next to it, maybe one of the address lines or something like that. I don't know. It was the smallest piece of solder, but I think that's what it was. So, I mean, I'm just giving it, you know, I've been giving it a whack, you know, bouncing the board up and down like this here, flexing it a little bit, can you see? Both ways, no issues at all. It's a good test, you know. I did that in that 500 plus to find the fault. I probably created one or two of those faults myself by flexing it so much. That's one problem you can have, you know, you flex a board when you've been soldering traces and things like this, and bad connections on chips. You could break the connections. But I'll be honest, if you're going to ship a board out to somebody or you want it to be reliable, you need to give it a test where you are, you know, banging it a little bit, flexing it a little bit, and the tap test. So I'm just going to go around and just, because this is what was happening before, I was like tapping the board a bit, and then it was suddenly the reset pulse would just, you know, come back properly, it would start to boot, and then I'd tap again, and then it'd go off again, and then suddenly it'd be black screening for 20 minutes while I would try and tap things and move things and reseat things. And then it would just mysteriously start working again. So, yeah, I mean, I'm not completely convinced I've fixed it here. but it's a funny coincidence, there was a particle of solder just on that pin. It's probably the only part of the board that's not had a brush down after I finished the work, but yeah, I mean, nothing's influencing it now, so yeah, fingers crossed that that's all it was, that single particle. And as you can see, it is actually working. I'm guessing I pressed fire. Yeah, you see, so it sustained all those taps and bangs and bounces. Fingers crossed that's all it is. So whilst that sounded okay, as you can hear, just look at the font there. Let me zoom you in a little bit. Yeah, can you see the font looks corrupted? I'm pretty sure we've got some pixels in, incorrect there. Could be wrong, but if I put disc 2 in, this game will just crash. And many other games just won't boot at all. They'll load a little bit and then reset, like, I don't know, Indiana Jones, Fate of Atlantis, Monkey Island. I've got several games here that I just cannot get working at all, and I don't think it's to do with it being Kickstart 1.3. In fact, I know it's not, because I've tested them on other 1.3 boards I've got and they work okay. So, yeah, I think we're into the realms of RAM again on this one. But I need to connect a keyboard up before I can do anything else on this one. So it's that same screen on a 500 with fast RAM here. I'm just testing one of the 500 boards previously shown on my channel here with fast RAM, just to test other games, because some of the games need fast RAM. But as you can see, we haven't got the corruptions. That font looks okay to me. So there is indeed a RAM fault with this 2000. We'll take a look at that in the next video. Also in the next video we'll have a quick look at the floppy drive, because the floppy drive's not working now, the 2000 that I've been using tests with. But also we need to connect up a keyboard, and the approach I'm going to go with is to connect up an A500 keyboard actually, which you can do. And then obviously we just need to finish cleaning up the board, testing things and stuff, and yeah, just making it look better than it does at the end of this video. Anyway, I do hope you found the video interesting. Please like, share and subscribe, and I'll catch you in the next video.